Name the polynomial by terms and degree. All right, so this guy, first off, has two terms. If something has two terms, that makes it a binomial. The degree here is the highest exponent attached to a variable. 2 is the highest exponent. If 2 is the highest exponent, that makes it a quadratic. So if I were to name this guy, I usually like to go with the degree first. I would call it a quadratic binomial. And that's it. Name the polynomial by terms and degree. All right, well, first off, terms. We've got 1, 2, 3 total terms, which makes it a trinomial. Now, my highest degree is the largest exponent attached to a variable, which is going to be 4. If 4 is your largest degree, that makes it a quartic. So I always like to name it using the degree first. We will call this a quartic trinomial. And that's that. Simplify parentheses 5p squared minus 3 close parentheses plus parentheses 2p squared minus 3p cubed. Fun fact, if you have nothing in front of a parentheses or just a plus sign in front of the parentheses, you don't need them. So we don't need that first set of parentheses, 5p squared minus 3. And we don't need this group of parentheses, 2p squared minus 3p cubed. Okay, now let's try to combine like terms. Let's go with the highest degree, which is this guy. Now there's nothing like negative 3p cubed. Negative 3p cubed doesn't have any other p cubes floating around, so we will write out negative 3p cubed. 5p squared is like terms with 2p squared. 5 plus 2 is 7, so 5p squared plus 2p squared is 7p squared. Negative 3 is just kind of like lingering all by itself, so we'll just put minus 3. These are all combined as best as they can be. You can't combine any further because all of the terms are different, and that's how we do it. Simplify parentheses 3 minus 6n to the 5th minus 8n to the 4th, close parentheses, minus parentheses, negative 6n to the 4th minus 3n minus 8n to the 5th, close parentheses. That first set of parentheses has nothing in front of it. So if all you have is nothing or just a plus sign in front of the parentheses, you don't need the parentheses. Let's get rid of them. Now we can't say the same about the next guy because there's a negative in front of this. So what we have to do is distribute the negative. Now what that means is take every term in here and make it opposite. Negative 6n to the 4th is positive 6n to the 4th. Negative 3n is positive 3n. Negative 8n to the 5th is positive 8n to the 5th. Now we have like terms floating around all over the place. So let's start with the highest degree and choose negative 8n to the 5th, 6n to the 5th, my bad, negative 6n to the 5th. Negative 6n to the 5th is like terms with positive 8n to the 5th, and so those guys combine. 8n to the 5th minus 6n to the 5th is 2n to the 5th. Add the coefficients, keep the n to the 5th. Let's work our way down. We now have negative 8n to the 4th and 6n to the 4th. Those are like terms. Negative 8 plus 6 is negative 2. So negative 8n to the 4th plus 6n to the 4th is negative 2n to the 4th. And then we just keep our working. Keep working. 3n, there's nothing like it, 3n. And last but not least, 3, nothing like that either, so plus 3. All of these have different variables with different exponents, so they don't further combine. And that's going to be our answer. Find the product. This, ladies and gentlemen, is distributive property. We are multiplying 6v times parentheses 2v plus 3. 6v times 2v is going to be 6 times 2, which is 12, and v times v, which is v squared. 6v times 3 is going to be 6 times positive 3, which is positive 18. V times nothing like it, which is just a v. So that's it. That's our answer. We're done. Find the product of parentheses 2n plus 2, close it, parentheses 6n plus 1, close that. When you multiply a binomial times a binomial, you use a process called FOIL. That stands for first, outer, inner, last. And basically what you do is you go to the first term, okay? So 2n, and you distribute that to both of these guys. So my first is going to be 2 times 6n, okay? My outer is going to be 2n times 1. My inner is going to be 2 times 6n, and my last is going to be 2 times 1. So 2n times 6n is 2 times 6, which is 12, and n times n, which is n squared. That's the first. The outer is going to be, oh, I did the wrong colors. That's all right. 2n times 1, which is going to be 2 times 1, which is 2. N times nothing like it is just going to be n. Now we have 2 times 6n, that's the inner. 2 times 6 is 12. N times nothing like it is just n. And then the last is going to be 2 times 1, which is 2. Now take a look at what you have and see if you can combine like terms. Nothing combines with u. However, 2n plus 12n combines to make 14n. Plus 2 just lingers. Looking at what we have left, they're all different terms. Nothing is alike. We just found our problem. Find the product of 4a plus 2 times the quantity 6a squared minus a plus 2. This is an extra FOIL problem. You're going to take your 4a and you're going to distribute that 4a to all three terms in the second parentheses. Then you're going to take 2 and distribute 2 to all three terms in the second parentheses. So we have 4a times 6a squared. 4 times 6 is 24. A times a squared is 3a's, so a cubed. Now let's do it again. 4a times negative a is going to be 4 times negative 1, so negative 4. A times a is a squared. Let's do it again. 4a times positive 2 is 4 times 2, which is 8. A times nothing like it is just a. So we distributed 4a to those three guys, dunzo funzo. Now let's do the 2. 2 times 6a squared is going to be 2 times 6, which is 12. And then a squared just kind of comes along for the ride. 2 times negative a is negative 2a. And 2 times 2 is positive 4. Now we take a look at what's left over and see if we can combine like terms. 24a to the third doesn't combine with anything. However, negative 4a squared and positive 12a squared do combine. Negative 4 and 12 make 8. So negative 4a squared, positive 12a squared, 8a squared. 8a minus 2a is going to be 6a. And then negative 4 all on its lonesome is just kind of hanging out. So that's how you find the product. This is just a very big FOIL problem, very big double distributive property problem, lots of combining like terms, and lots of fun. Find the product of x plus 5 in parentheses times x minus 5 in parentheses. Now this is a binomial times a binomial, so it is a FOIL problem, but this is a special type of FOIL problem, so let's see what happens. X times x is x squared, no big deal. X times x is x times negative 5 is negative 5x. 5 times x is positive 5x. And 5 times negative 5 is negative 25. Now what you're going to notice is the guys in the middle cancel out. And we're left with x squared minus 25. This is called a difference of squares. When you have something like x plus 3 times x minus 3, and the only difference between the two is a plus and the minus sign in the middle, you can kind of skip the O and the I part of FOIL. So if I did a problem like this, I would get x times x is x squared, and 3 times negative 3 is negative 9. I don't need to worry about the plus 3x and the minus 3x because they're just going to cancel each other out anyway. All right, so this is a difference of squares FOIL problem. Pretty easy once you understand how to do them quickly. Find the product of p minus 1 in parentheses squared. Now this is called a perfect square trinomial. This is not as simple as saying p squared, 1 squared, p squared minus 1. No, no, no. When you square something, you write it out twice. So this is actually parentheses squared, and inside the parentheses is p minus 1. Now, this is a FOIL problem. P times p is p squared. P times negative 1 is negative p. Negative 1 times p is negative p. And negative 1 times negative 1 is positive 1. And we end up with p squared minus 2p plus 1. Now, again, this is called a perfect square trinomial. There's a shortcut to do these. Okay, now again, foiling is not so bad, but here's the shortcut. Let me just create a brand new one and put it over here. X plus 4 squared. What you do is the first term is going to be the first term squared. The last term is going to be the second term squared, right? So I have that. The middle term is going to be 2 times the first term times the second term. So 2 times x times 4 is going to be 8x. So if you notice right off the bat that it's a perfect square trinomial, you could use that shortcut. And let's use that shortcut to double check what we have. What did I say? I said we could take the first term, square it, check. We could take the last term, which is negative 1, square that, check. And then the middle term is going to be 2 times the first term times the second term. So 2 times p is 2, p times negative 1 is negative 2p, check. Okay, so perfect square trinomials follow different rules, but if you memorize the shortcut, it goes pretty fast. Find the product of negative 9x squared minus 10y, all of which inside of parentheses squared. Now we are going to use the idea of perfect square trinomials. Now what a perfect square trinomial says is if I give you something plus or minus something inside of parentheses and then you square the parentheses, you square the first term and write it out first. You square the second term, write it out last, and the middle term is going to be 2 times the first term times the second term. All right, so let's apply that here. Okay, let's square the first term. So squaring negative 9x squared means negative 9 times negative 9, which is 81. And squaring x squared means x squared times x squared, which is x to the fourth. Squaring the last term is going to be negative 10 times negative 10, which is positive 100, and y times y, which is y squared. Now the middle term is going to be 2 times negative 9x squared times negative 10y. So 2 times negative 9x squared times negative 10y is going to be 2 times negative 9, which is negative 90. I'm sorry, negative 18, times negative 10, which is positive 180. And then x squared times y is x squared y. Now, if you wanted to, you could have written this out as 2 parentheses and FOILed the whole thing, and you get the same exact answer anyway. But, you know, if we're going to learn the shortcut, we better know how to use it, and that's how you use it. Factor b squared plus 8b plus 7. All right, we are looking at a quadratic trinomial, which means when we have a quadratic trinomial, 3 terms, degree of 2, with nothing in front of the highest degree, you are thinking of 2 numbers whose sum is going to be 8 and whose times is going to be 7. I call this process sum times. So 2 numbers whose sum is going to be 8, they add up to 8, and whose times is going to be 7 is going to be 1 and 7. So you set up parentheses, You put your b's here. And if these guys add up to 8 and multiply out to 7, b plus 1, b plus 7, it doesn't matter the order that you write them out in, as long as they're both positive. Okay, so again, factoring a quadratic trinomial with the number 1 in front of b squared involves you adding two numbers and multiplying the same two numbers to get these guys right there. Factor m squared plus 2m minus 24. This is a quadratic of 3 terms, so I'm going to use the process called sumtimes. You think of two numbers that add up to 2, sum, and those same exact two numbers multiply out to negative 24. Once I figure out those numbers, I'm going to put m and m. Now, if it's going to multiply out to a negative, one has to be positive and one has to be negative. So one's going to be positive and one's going to be negative. So I'm thinking, all right, though, I need to come up with two numbers that subtract out to 2 and multiply out to 24. So 6 and 24 should do that. But which one gets the plus sign and which one gets the minus sign? Well, the 6 gets the plus sign and the 4 gets the minus sign because positive 6 and negative 4 make positive 2. All right, if I were to switch these around, that would be negative 2. These guys multiply out to negative 24. So two numbers that add up to 2 and multiply out to negative 24 are 6 and negative 4. Set up your problem. We're donezo. Factor b squared plus 16b plus 64. Now, this is a process I like to call sumtimes. When you have a quadratic and it's 3 terms, you think of two numbers whose sum, add, is 16 and whose times is 64. All right, once you figure that out, you set up b here and b here. Now, if it's going to multiply out to a 64 and add up to a positive, both numbers are going to be positive. And 8 times 8 is 64, and 8 plus 8 is 16, so 8 and 8. Now, it looks like we're done, or it looks like we should be done, but hold up a second. If my job is to factor, I have to make it look as compact as possible. b plus 8 times b plus 8 are the same thing. And we can write that out as b plus 8 squared. So this is a perfect square trinomial. Factor 2n squared plus 6n minus 108. Now, factoring could mean several things, but the main idea of factoring is see if there's a greatest common factor that you can pull from each number or term. In this case, I notice that all of these numbers are even, which means 2 is in common in all of them. So I can pull out a 2. When I divide a 2 from each term, I'm thinking 2 divided by 2 is invisible 1, n squared. And 6 divided by 2 is going to be 3, so 3n. And negative 108 divided by 2 is negative 54. Now I look at what's left over and I think, well, wait a minute. That's a quadratic and that's 3 terms. Maybe I can come up with two numbers that add up to 3 and multiply out to negative 54. Maybe I can make this look like this. And I can. Okay, if two numbers multiply out to a negative, one's got to be positive and one's got to be negative. Okay, two numbers that multiply out to 54 are going to be 6 and 9. Now 6 minus 9 or 9 minus 6 is 3 or one of the 3's. But which one gets the positive, which one gets the negative? Well, the positive one's going to be the larger digit because I end up with the larger digit right here. So 9 is going to be positive, 6 is going to be negative. So when all is said and done, when you factor this guy, you actually end up factoring twice. And we end up with a final answer of 2 times the quantity n plus 9 times the quantity n minus 6. And we are done. Factor 5n squared plus 19n plus 12. This is one of those cases where when you see factor, you try to look at anything and see if there's a number or a variable that you can pull out. And there isn't in this case. There's no greatest common factor to deal with. So this is one of those things where you have to kind of come up with a combination and set up a problem where maybe perhaps you have something that looks like this, where you don't have just n and n, maybe you have a number in front of one of not both of these. So let's try to figure out some combinations. 5 could be 5 and 1. Okay. 12 could be a combination of 2 and 6, or 6 and 2, or 4 and 3, or 3 and 4. Or maybe it could be 12 and 1, and 1 and 12. There's a lot of options here. And what I want to do is I want to try to figure out which combination, when multiplied together, gets me 19. So if I were to test you out, if I were to test this guy out, what I'm going to do is multiply the outside numbers. So 5 times 3 is 15. And multiply the inside numbers. 1 times 4 is 4. And those two numbers happen to be 19. So these are the combination of numbers that I want. So the way I set this up is, since these numbers are attached to the n, I'm going to keep those numbers attached to the n. Yes, I'll clean this up in a minute. In that order, by the way. 5n, 1n. Since these were the numbers attached to 12, in that order, I'm going to write it out that way. And when I clean things up and get rid of that 1 in front of the n, I end up with 5n plus 4, regular n plus 3. Now there's another way that you could do this called MUDs. I'm not a fan of it. This is the Nick Parrich version of doing things, or the math teacher goat way of doing things, and I prefer it this way. So I don't know. If it helps, it helps. And if you would rather do MUDs, then hey, get dirty. But not like and subscribe, please. Factor negative 6a squared minus 25a minus 25. Ugh. All right, this is what I want to do. First things first, I want to get rid of that negative, so I'm going to pull a negative out and have it leave me with 6a squared plus 25a plus 25. Now, is this factorable? I don't know. But this is what I can do. This is one of those things where it's not as simple as trying to come up with two numbers that add up to 25 and multiply out to 25. Since I have something in front of a squared that I can't do anything with, I have to list out the possible combinations that get me 6. So here's 1 and 6. Here's 2 and 3. For 25, I'm going to list out all the combinations that get me 25. So 5 and 5, 1 and 25, 25 and 1. Now what I need to do is I need to guess a possible combination that, if I were to multiply things together, get me 25. Now the 1s and 25s are awful big, that scare me. So what I'm going to do is I'm going to test to see if this guy works, right? I'm going to test to see if that guy works. So if I were to do 1 times the 5 out here, I get 5. And if I were to do the 6 times 5 on the inside, I get 30. Now, that doesn't work. So this is a bad combination. That gave me 35 when I needed 25, so this is not an option. So let's try another option. Multiply the outside numbers, 2 times 5, which is 10. 3 times 1, 3 times 5, I don't know why I put 1 there. 3 times 5, which is 15. And that seemed to be the one that does work, because that gets me 25. So this is the combination that worked. So the negative is still lingering on the outside. I have a's right here. Since my 2 and 3 in that order were attached to my a squared, I'm going to put the 2 and 3 in that order. Since the 5 and 5 were attached to the number here, I'm going to put plus 5 and plus 5 in that order. And so at the end of the day, you become you. Easiest thing in the world? Absolutely not. But that's how you would do it. Factor 16n squared minus 9. Now when you see factor, that could mean a few things. Sometimes you look for a greatest common factor and see if you can rip it out. Well, in this case, that's not what we have here. We can't pull out a common factor. What this is called a difference of squares. Now I know it's a difference of squares because it's in the form a squared minus b squared, where you are a square because 16 is 4 squared, n squared is n squared, minus is minus, 9 is 3 squared. When you factor a difference of squares, you end up with a plus b times a minus b. So the way I apply that rule over here is you're going to look like something plus something, something minus something. The first term in each parentheses is going to be the square root of that first term right there. The square root of 16 is 4. The square root of n squared is n. The second term in each parentheses is going to be the square root of that guy. The square root of 9 is 3. and 3. So that's how you factor a difference of squares. And again, you are looking for something minus something where both of those things are squares, which is why it's called a difference of squares. Doesn't that make sense? Factor 16b squared minus 40b plus 25. Now this looks like one of those things where you're thinking, I have to come up with all of these multiples and all of these factors and try to see which combination works, but not necessarily. I noticed that this first term is a square, 16b squared. I noticed that this last term is also a square. So this is potentially a perfect square trinomial. The way you test to see if something is a perfect square trinomial is you write out the first term by taking the square root of the first term, so 4b. You write out the second term by taking the second term and writing out, so 5. And then the minus sign just kind of comes along for the ride. Now, how do I know this works? Well, the middle term is going to be 2 times 4b times negative 5. So 2 times 4b times negative 5 is 2 times 4, which is 8. 8 times negative 5, which is negative 40, and then b. So this is indeed a perfect square trinomial, and this factors out to look something like that. Factor 10p cubed minus 1960p. All right, well, first things first, I notice that there's a 10 in common in both of these, so let's factor out a 10. I also notice that there's a p in common in both of these, so let's factor out a p. When I factor that out, pulling a 10 from a 10 is an invisible 1. Dividing a p from a p cubed is going to leave me with 2 p's, p squared. Minus sign comes along for the ride. Dividing a 10 from 1960 is going to be 196. And removing a p from a p just leaves me with no numbers, or no letters, I mean. Now, this is not done yet. 10p, we are done. But I'm looking at this guy and I'm thinking, wait a minute, that's a difference of squares. P squared minus 196, which is 14 squared. So if it's a difference of squares, I can factor this out to make it look like this. Plus sign, minus sign. If you're a square, then you take the square root to put it in the first part. And if you're a square, then you take the square root to put it in the second part. So when all is said and done, we have 10p times the quantity p plus 14 times the quantity p minus 14, and that factors out to that. Factor 8r cubed minus 64r squared plus r minus 6. The way we're going to factor this is called factor by grouping. What we're going to do is we're going to rewrite the first two terms in the same parentheses, like that, plus the second two terms in its own parentheses. We're going to factor each parentheses out as best as we can. I have an 8 in common in both, so I can pull out an 8. I have 2 r's in common in both, so I can pull out r squared. When I do that, when I remove an 8r squared from an 8r cubed, I'm left with just an r. And when I divide an 8 from 64, I have minus 8. When I divide 2 r's from 2 r's, that's that. Now that's going to be plus r minus 8. Now I'm going to put an invisible 1 here, because what I notice is both of these terms, both of these things, has an r minus 8 in common that I can pull out. So I can pull out r minus 8, and by pulling out an r minus 8, that leaves me with 8r squared plus 1. So factor by grouping is not the easiest thing, for sure, but that's how you do it. Factor 12x cubed plus 2x squared minus 30x minus 5. The process that we're going to use is going to be called factor by grouping. What you do is you group the first two terms in its own set of parentheses, like so, and you group the second two terms in its own set of parentheses. Notice, by the way, how I'm putting plus sign in the middle and making negative 30x. You don't want to do minus parentheses because then that affects this guy right here. Okay? Factor each parentheses as much as you can. I can pull a 2 out. I can pull an x squared out. When I pull a 2 and an x squared, that leaves me with 6x plus 1. For this guy, I can factor out a negative, because there's a negative in common in both, and I can factor out a 5. When I do that, dividing a negative 5 from negative 30x is going to be positive 6x, and dividing negative 5 from negative 5 is positive 1. Now I notice I have these parentheses in common. This is a common factor. So pull out 6x plus 1, and when I pull out a 6x plus 1, that leaves me with 2x squared minus 5. And that's that. Divide using polynomial long division. All right, well, what we're going to do is we're going to set up our polynomial long division problem. This is our factor, m minus 8. This is going to go underneath the fraction bar, or the quotient bar, and that's going to be m squared minus 7m minus 11. Make sure everything is in order from the largest degree to the smallest degree, and if there's anything in between, we fill in the blanks, but we don't have to worry about that here. Now we ask ourselves, m times what is m squared? M times m is m squared, and so we write that down. Take that m and multiply it to the whole factor here. M times m is m squared. M times negative 8 is negative 8m. Now what we do is we subtract the entire row, which means flip all the signs. So when we do that, we have negative 7, well, this will always disappear, otherwise we did it wrong. M squared minus m squared disappears. Negative 7m plus 8m is just regular m. Drop down the minus 11. Now m times what gets me m? M times 1 gets me m. And so I'm going to do the same thing that I did up here. 1 times m minus 8 is m minus 8. Subtract the entire row, which means flip the signs of everything, so minus and a plus. You go away, and you become negative 3. So this is going to be m plus 1 with a remainder of negative 3. Now, many teachers might be okay with that, but there's another way that you can write this out. My answer is m plus 1, and since my remainder is a negative 3, I can add negative 3 over my factor, which is m minus 8. So 2 ways of answering this. It all depends on how your teacher wants to do it. If you have a remainder, you put it as the numerator over the factor. Either one of these is technically correct. It just has to do with what your teacher wants. Divide using synthetic division. Let's set up our synthetic division problem. We have n plus 2 is going to be divided from n cubed plus 7n squared plus 14n plus 3. Fortunately, everything is in order the way we want it to be. We're not missing anything in between. All is well, we can do the problem. Now the way we start this off is we say n times what gets me n to the third power? Well, n times n squared gets me n to the third power, so write n squared right above there. Take that n squared and multiply it to this entire factor here. So n squared times n is n cubed. N squared times 2 is 2n squared. Now, once we do that, we subtract the entire row here, which means flip all the signs. So you now become a minus. You will always go away. 7n squared minus 2n squared is 5n squared. Drop down the 14n, the positive 14n, and repeat the process. N times what is 5n squared? Well, n times 5n is 5n squared. Take that 5n, multiply to that whole factor. 5n times n is 5n squared. 5n times 2 is 10n. Subtract the entire row, which means flip the signs. You will always go away. 14n minus 10n is 4n. Drop down the plus 3. One more time. N times what is 4n? N times 4 is 4n. Take that 4 and multiply it to both of these. N times 4 is 4n. 4 times 2 is 8. subtract the entire row, which means flip the signs, and we end up with u going away. 3 minus 8 is negative 5. So I'm going to have a remainder of negative 5. Now for some classes and for some teachers, this might be acceptable. If you have a teacher that says nope, then your answer is going to be n squared plus 5n plus 4 plus negative 5 over the factor, n plus 2. Okay, so either one of these is acceptable. It's just it all depends on what class you have and what teacher you might have and, stuff like that.